Hi, I'm Bryce Ominski, Chief Technology Officer from the Deep Dive Group. Today I'm with Steve Peterson and Dan McCreary. We're going to be discussing the importance of good communication skills and storytelling in the context of AI and knowledge representation, specifically large language models and knowledge representation. Dan McCreary has a long history of working with knowledge representation. He's currently working for TigerGraph, and he is an expert on NoSQL as well as storytelling. We also have Steve Peterson with us, who is the head architect for Rodan Fields. I've known Steven now for quite some time. He leads the Minneapolis AI Forum with ISA Global. He's done a lot of stuff. And between Steve and Dan, I'm probably talking to two of the top ranked people on the planet in terms of looking at emerging technologies and actually getting things done with advanced technology. Let me just take a minute. I'll give you each a chance to introduce yourself a little bit more fully, and then we'll get right into it. Dan, do you want to start with just a brief introduction?
Sure. Yeah, I think you did a very good introduction. My background is solution architecture. I have this little gift that I can visualize data moving through complex systems. And I have always known that storing data in tabular formats, such as relational databases, is good for many use cases, but has limitations, especially with scale. So I've really spent a lot of my career helping large organizations build strategic plans to use better knowledge representation, make better predictions. And I just fell in love with large language models back in 2020, before GPT really became popular. And I led at the last company I was with, Optum, I led their Generative AI Center of Excellence. Yeah.
Great introduction. Thanks, Dan. And Steven, do you want to just talk a bit about yourself?
Sure. I have a long history like Dan, coming from Control Data, Unisys, IBM, NMDP, UHG, AT&T. So a lot of big companies. I'm nowhere the expert that Dan is, but I did help teach the first AI class at St. Cloud State in 1985. So that's my claim to fame.
Oh, fine. Good old fashioned AI. Yeah, get my list. So yeah.
Absolutely. I run the AI and architecture, and Dan's a part of that also. It's a special interest group out of Applied AI here in the Twin Cities. And Dan and I are really fortunate because we have a lot of really smart people in the cities, and we have a really strong group. I'm also part of the Chief Architect Forum, and the SIG is sponsored by the Chief Architect Forum, and so we're able to draw upon a lot of the thought leaders in the Twin Cities and internationally for our special interest group.
Great. Thanks, Steve. Let's get right into it. And what I want to share with everybody, just before we came on, we had a little bit of a discussion around the presentation that we want to make. And what's really interesting, we settled on the idea that storytelling really has to come first before we start getting into the knowledge representation and the generative AI and how they fit to really help make sense of what we're doing and bring in there's a metaphor we'll be talking about with the jellyfish and the flatworm. But I think what's really important, and this is something I really struggled with, Dan, as an executive, we tend to forget that there's levels of communication. Like there's the individual contributor. I mean, that's the first thing we've done. Where I produce documents or SOWs or plans, and I just pump it out. There's management level where I need to deal with people, but really what we need to deal with at an executive level is a higher level of communication, and that's storytelling and impact.
So the importance of a storytelling is what Dan and I have run into, and we've had a lot of experience of this, and kind of some hard bumps along the way, is when the conversation gets too high and we talk about too much detail about disruptive technology specifically, and disruptive technology even after years. What a lot of times we get are executives that find a reason why not to do it because it's scary. They don't have a common story, right? So it's important that we create these metaphors, these stories that not only the executive understands, but that multiple executives understand, so that there's a common understanding and we create that linkage between them. And once we do that, then we can get more momentum. We've run into pushback from execs in the past, right, for this very reason. And especially as people become chief architects and in these roles, they're very uncomfortable about not knowing something. Dan's got, as you mentioned, this great story. And I think it's one of many that we've told, and it's about the jellyfish and the flatworm. So Dan, do you wanna tell your great
Yeah,
story?
we'll do the thing. So let's set the stage here. Today, if you're going to kick off a $1 million generative AI project, studies show that about 6 executives need to agree on that. About 6 people have to sign off, right? It used to be 1 or 2, but now with conservative spending things, we have to imagine a room of 6 executives sitting around. And here's the interesting thing: none of them are IT people. None of them probably have a background in software development. None of them can visualize data representation. But what can they remember in that meeting when they make a decision? And what they can remember is stories and metaphors. So they're going to be sitting around the table talking, and it is now the job of the architect to find the appropriate stories. They have to be truthful, right? They have to reference the real world. But it's going to be those stories and metaphors that they're going to discuss. And if you give them the right stories, hopefully they'll make the right decision. So let's start out with this, the jellyfish and the flatworm. So imagine a jellyfish floating in the open ocean. And the jellyfish has a relatively simple central nervous system, about 8,000 neurons in its nervous system. It doesn't really have a brain. And its job is just to float around, drop its tentacles down, and hope that a fish floats by that it can catch. And its job is to minimize the energy that it expends while it's floating in the ocean. And we want to contrast that with what happened about 500 million years ago. Is how did the flatworm evolve? Well, the flatworm is known as the first animal with a central nervous system. Why did it build that? And the answer is, when it was crawling around the ocean floor, it had a much more complicated environment. It had to crawl to certain places where it knew it had food. It had to avoid certain places on the ocean floor where there were predators. And because of that, it had to build a map of its environment and use that map to make a prediction of where it would go to survive. And that's the fundamental thing we're asking about companies today. Are you a jellyfish company? Maybe you sell just a simple one product, maybe you have one customer, and you don't really need a complex infrastructure to predict what the change in a price might be because maybe you don't have any competitors, right? That's the simple company. And just for a metaphor, you might have a barbershop that's in your local area, and they don't need a lot of IT. They just need to have good hands-on service, and they have a simple company, right? And let's contrast that with other companies that have complex products. Maybe those products depend on knowledge. Maybe they're a school or a university that builds and creates content that they effectively present by their instructors. They live in a complex world. And if these organizations don't build a centralized intelligence in their organization, where they can do what if scenarios, where they can collect all the data, where they can use machine learning to make a prediction. Well, if we increase the price of this class, what's going to be our enrollment going to happen? What if we extend the warranty on this product compared to our 100 competitors that have similar products? If you can't make those predictions, these companies that deal with complex knowledge are going to go extinct. They're not going to thrive. And that is really the central reason why the most successful companies in the world, think of the big Magnificent Seven. Amazon has a 100 billion vertex product graph, right? They make $42 billion on product recommendation. Google, since 2012, their search is built on a knowledge graph. Even a company like Pinterest, where you have interest, all of their infrastructure is now built on a knowledge graph. So these companies, LinkedIn, Facebook, Twitter, all of them that scale, having integrated knowledge representations that span many computers and have high availability and all the other things we need in a database, they have been able to grow. And they have really locked out a lot of the competition that's been trying to use older relational databases to manage their customers.
That's a great point. And, Dan, we're seeing a lot of companies now that are really talking about the need to look at both knowledge representation and large language models. And so I think there's a lot of people, when this whole generative AI came up with the large language model, when it came out, oh, it's the holy grail, it's going to save us all. But it has limitations. And I mean, they need large amounts of data. How does knowledge representation fit into that? And maybe, can you give us a little bit more of an in-depth view why companies like you mentioned Microsoft, there's another one that's very interesting, Palantir, there's the graph companies like your own, Taggart Graph. Why is it so important that we are able to leverage knowledge representation techniques with large language models?
Yeah, once again, you'll find that Steve and I speak in metaphors, right? So we always start with a metaphor, and then we try to help people build that worldview of what they need to do with that. And the way that I like to describe it is that there have been many companies, Steve and I work with them, that build what are called data lakes, data warehouses, and they're really good at things like counting and totaling counts and amounts. That's really what they know, OLAP cubes and things. Very good for retail, where you want to say, gee, if I move the toothpaste from the second shelf to the first shelf, what's going to be the impact on my sales, right? And you can see that, you can count the sales. But the world is changing where counts and amounts is important, but not enough. And what's happening is that companies now need to do things like compare things. They need to find how similar two items are. And that similarity measures is what language models do very well, right? They create these wonderful, beautiful things called embeddings that allow us to compare any two things in our organization. Those are created and maintained by large language models. So the metaphor I use when we think about this is, think of an accelerant, something that makes things go faster. Pouring gasoline on a fire makes it burn brighter, right? Large language models are accelerants to knowledge representation. They don't replace them, right? You can't do transactions with a large language model. You can't subtract a fact from a large language model. They're just this big opaque black box. They don't model the real world. Knowledge graphs model the real world. And in order to make a prediction in the real world, you need to have a precise model, like ontologies, that you can maintain and change. Large language models are really good at tasks, specific tasks that surround your knowledge graph. They accelerate data going in. They accelerate matching a question to a query that can be run. But the bottom line is they're complementary, and that large language models are going to dramatically accelerate your ability to load more varied data with more relationships, right? And those relationships are just going to slow down relational databases until they die a horrible death, and you're not going to be competitive unless you make that leap off of the old tabular representation to this new high efficient distributed pointer traversal. Those are the key things that are happening in our industry.
And that's a great point. And Steve, we had a discussion before this call where we were talking about some of the use cases in terms of like being able to leverage some of these graph languages or NoSQL things to get more information that the large language model can use, right? Do you want to sort of outline maybe one or two of these use cases and what we can do maybe better than we could have before, or maybe enabling us to new, I don't know, is this actually giving us new capabilities, Steve?
Well, yeah, I mean, if we look at a large language model, right, it's harder to derive what the most influential airport is, right? Which airport is really the one that's driving things, and it's not necessarily the one with the most traffic, right? It happens to be the one that maybe is an intercept point. And the other piece is, what's the influences? So we had looked at a use case, hate websites, right? Websites that are producing hate. And what hate sites are the most influential, right? Which ones are really influencing people in a direction? But why are they influential? What person or groups of people are really pushing hate websites, right? And so in a graph, I'll give you an example. We could have a geospatial graph, and that could really draw out what's the most influential airport or what's the most influential hate website. And the other problem is any environment, like in hate websites, where they have kind of a complex ontology, where they're trying to code certain words, right? That apple means bomb. I just made that up. I don't know if apple means bomb in that environment. And so what you can do in a graph, Tiger graph specifically, is do nearest neighbor. So you can find out what the posts are across websites, and we can find where people have similar views or posting similar things to see what their influence is within a geospatial graph. So a simple view of that would be it's just a query. And that's something that draws upon a different from a large language model, just a query against a database, right? But now we're seeing creating a graph and then running machine learning right in that graph with those data points, right? And when you do it at scale, that's where graph databases, and I'm not trying to sell Tiger Graph, but where Tiger Graph would really excel because it's performant at scale. Okay, so that's kind of one story.
Yeah, those are
Of course, we
great
looked at
examples.
this with COVID too, right? And Dan, you probably have some other use cases. A lot of times we're looking at members' journeys, maybe through the medical field, right? And it's the same kind of thing where we want to look at the experiences, the influences, and the outcomes of different treatments.
Yeah, I love your example of who are the key influencers in a network. And of course, in Graph, we have this algorithm called PageRank, written by Larry Page when he was at Stanford, and then licensed by Google. And then when they licensed it for stock, when Google went public, Stanford sold those patents for 350 million, or the stock they sold for 350 million. So one little graph algorithm can make a world of difference, but we can't really run graph algorithms on language models, right? They're just a big pile of math. And because of that, they lack the essential feature of explainability. Whereas when we traverse a knowledge graph, we can tell you exactly what points we traversed, and we can build an explanation model of what's happening. So once again, if you're going to try to find the underlying intent of a question based on context, yeah, absolutely large language models are great. But as Steve pointed out, because we can't do simple traversal algorithms like influence scores, we have to use a knowledge representation that we can take action on, and that's usually a graph structure.
Gotcha. So we go back to the jellyfish and the flatworm, and we look at this in terms of knowledge representation, large language models. What's the moral of the story?
Well, there's a little bit meta here. The moral of the flatworm story is that if you want to survive in a complex ecosystem,
Yep.
that you have to have a centralized nervous system that will predict the future, right? And help you predict and simulate the consequences of your decisions, right? The meta thing is that unless you have those compelling stories, and there are many stories, that's just one. If you don't have that, your executives will not be making aggressive decisions about emerging tech, just what Steve said. They will make a decision, and that decision is no decision. We call that the deer in the headlights syndrome, right? 6 people, and you get 4 people that agree, or maybe 5, but because they don't share a common story, a common metaphor, they're always worried that that their investment won't be good, and so they make no decision. And that no decision is in fact a decision that they're not going to adopt and include emerging tech in their stacks.
Steve, is there any thoughts you wanted to add to that?
Yeah, back to the story and back to the really yes or no thing, right? And if we have that story and if we can really show that leverage, then then we can really get that motivation going the right way. And it, Dan and I have talked about this, and we ask ourselves, is it really the technology that moves things, or is it the marketing that moves things? And we always were people that wanted to explain things. We always drove towards explainability, which is the important thing. But we have asked ourselves that question, right? It's if you can't market it, and it's upon all of us to be evangelists, and upon all of us to be preachers, as well as teachers and instructors, and and practitioners, in order to really move things forward. The way Dan and I have approached it with a community is we really feel we need that whole community, yourself and the Chief Architect Forum, to really broadcast and make sure we all work together on our consistent message, and make sure that it goes somewhere, right? And it can't just be behind the black curtain, right? It has to be explainable.
Steve, I love the words you use. Preacher, all right, telling them the vision of the future. Teacher, explain how to get there. And practitioner, don't just stand on the side and say, yeah, go do this. Help build the stepping stones to get to your vision. So I love the way you describe that, the key skills that an architect has to have.
Yeah, a great discussion. It actually sort of goes into my next question a little bit in terms of tactics versus strategy in AI. How do you differentiate them? And I think you started that a little bit. Is there any, do you want to go a bit further with that though, and sort of help maybe draw out what the difference is and what tools we use in each space?
Yeah,
Yeah.
Dan and I have gone through the back and forth on this quite a bit because, Dan's a distinguished engineer, great. And we do a lot of times, we do building blocks, right? And our building blocks are stepping stones that we can climb up, right? So there's a huge value. We've found in our career that we can have the best concept in the world, but if we can't test it out and show prototypes, we don't get anywhere. That only goes so far, though. We have to have that capability. And in fact, there has to be a join between what your plan is and what these execution building blocks are. When we step back to strategy and vision, we really have to look at what are our drivers, what are our motivations, what's our why? Why are we doing something, right, to support our assertions? And there's a line there where we can do too much and too much, right? But it's important to have a strategy. It's important to have capability models and understand the landscape so that we can communicate of what the value is for an organization, because every organization has goals. It has to survive, right? And so hopefully that draws the decision. We start out with that vision, what those roadmaps are, what our capabilities, what we're trying to achieve as a strategy point of view, but we have to be able to prove it, right? And so there has to be a close harmony between us. And I think that's kind of the harmony between Dan and I a lot of times, where I'm focused really in one area and he's focused in another area at times, and it allows us to work very seamlessly together.
Yeah, I love the way you describe it. Is when you start out with a strategy, you have to work with your executives to make sure that their business strategy and the AI strategy are in alignment, right? You don't want to say we're going to change the company because of AI. We say, here's where you want to go, and here's how AI can reinforce us getting there faster, better, cheaper. But once you have that strategic vision down, I just recently wrote a blog called Using Gen AI to Create a Gen AI Strategy, right? So it's a fascinating thing of how you can describe your strategy, have AI come up with ways that it can complement, and then it can generate very, very detailed, what we call micro strategies, tactics, where it'll generate 100 little ideas of how you can move from one level of that CMM stack, capability maturity model, to the next level. And in most cases, 70% of companies are either at level 1 and 2, right? They're either curious or they're starting to build pilots. Very few people are at that stage where they have that integrated center of excellence yet on stage 3. And how you get from 2 to 3, there's a lot of little strategies, but you can describe those to GPT-4 and it will start to suggest things. Now, not going to be perfect, right? They may not apply, but it's a great way to brainstorm and use that as a way to generate a series of tactics to help your organization. I have many people that have followed that recipe and have really, really good, solid results.
Interesting. So I'm going to change direction a little bit. In my career, I started, probably date myself, in the 80s, looking at artificial intelligence and expert systems, and eventually getting into ontologies and their representation. Hey, I played with Protege.
Yeah.
Isn't that all I need is a tool like Protege to do this all? Is that enough to, like, what are we doing all this graph stuff for when I have a tool like Protege?
Oh, that's a great softball. Steve, do you want to take that one?
I'll let you take that one, Dan.
All right. Yeah. I'm a very strong believer that Protege was a wonderful starting point, but it's not a destination, right? So Protege, just to be clear, is a open source editor. It allows you to edit a series of concepts and their relationships together. And it allows you to run tools like inference so that you can find new facts and things like that. But remember, Protege was what we call a design time tool. It helped people build and test that ontology, and it saves it in an OWL file. But what do you do with that OWL file, right? And the answer is, well, you have to start to convert that model of the world into real-time executable things that your database system, your rules engines can actually use. So it's a really good way to start out with a model of the world, but then you want to make it executable. And that's where graphs are, right? Protege was never designed for high availability and transactions and all those things. So a knowledge graph needs to be ACID compliant, right? You can add new data to it at any time. It has to run on a distributed server of 100 different servers. If any of those servers go down, it has to have replication. As you add more data, it has to automatically add new nodes to the cluster and then rebalance. Those are all the things that a modern graph, scale-out graph database has to do. And your company needs to know they can depend on it. Whereas I think of Protege as kind of like the equivalent of the Microsoft Word processor. It's just a very structured word processor. But I can't tell you how important it is to always start with something simple. If people are brand new to graph, I say start with your business glossary, right? Create a spreadsheet, put 2 columns. One is the term, the other is the definition. Just keep doing that until you see patterns arrive. Oh, these terms are kind of related. Oh, they tend to classify. Business glossaries evolve into taxonomies. Those evolve into ontologies. Those can be the basis of a high volume production knowledge graph that is used by your AI, right? Because your AI can run queries on a knowledge graph. You can take a description of a query, it can convert it into the graph query language, it can run it, it can see it, and it can also generate the code that displays it in a view, right? So large language models is going to be this accelerant to get things in faster, to automatically map things, right? Here's a CSV file, go map that into my knowledge graph. Boom, similarity. Oh, this person name and person given name, oh, they're the same. Let's automatically map that and load it in. Gen AI is really going to accelerate our ability to build more things and more relationships and then make it actionable.
I think in our story too, Bryce, a lot of times we look at where we came from, right? My start way back was Lisp, right? Running through a family tree, and a lot of times in this experience, we find in our metaphors, we take it from something abstract, like a flatworm, something that people don't have pre knowledge of, right? And then we move it to something that's binary, something that is an expert system. So when I wrote code for medical software, you knew based on your validation or cross validation whether a blood product was FDA eligible and suitable for donation, right? And in there's an expert system. And a lot of times when people are listening to these stories for explainability, it's nice if it's something that true or not true, right? And then we extrapolate it to something that that we're learning that we didn't know the answer ahead of time. 2 degree tic-tac-toe to 3 3D tic-tac-toe, you know, something like that where it's beyond what we can really comprehend.
Interesting. There's a comment I heard in there, and if I heard it correctly, what I heard is that graphs are acid, they're not base. And that caught my interest with this whole thing. Why? Could I not have a distributed graph that is base, or like what was your thinking in saying that? And do we need to have that acid? And I'm thinking it's not for transactionality. There seems to be another reason behind it.
Yeah, that was my comment. And I should probably back that off. When I was saying acid, what I really meant is that it doesn't lose data, it doesn't drop transactions, even on
Okay.
server. But you are right. Most distributed graphs use a slightly different model, but the idea is to guarantee consistency on transactions, even and never block read queries, even as new data is coming in. And the most common architecture is just like in relational or document stores, something called MVCC, multi-version concurrency control. So you just have to have a way that you can have confidence that you can continually be updating your data. This is not a read-only world, right?
Yep.
You can't say, here's a read-only system and we reload the data once a month, right? That's not going to fly. You have to be able to make real-time updates and have the confidence that the queries that come out will be consistent. And that's the summary of that one.
So let me put this to both of you then. Have we seen with the use of graph algorithms any improvement in runtime performance?
That's a good question. Graph algorithms are kind of central to a lot of this. Steve mentioned PageRank. And when you look at the complex algorithms that we're doing, centrality, pathfinding, all those things, they haven't really changed. What has really changed is our ability to manage those transactions over the billion vertex things. Now I'll tell you, in my career, when I started out, I remember some of my first databases. I remember I was so excited when I got 10,000 rows in there, right? And as you mature, you get 100,000. And then one day I did my first million row database. Well, what we're seeing then is as you go from 10 million to 100 million to a billion, there's these new very important properties. I call it emergence, where you can find insights that you never had before, right? And you can't really predict how emergent happens as your database scales, right? So that's really a crazy thing where executives need to know that the more data they have, the higher the chance they'll emerge to have queries that have deep insights. That's really what has happened. We have so many more things that demonstrate emergence that we've never had in the past. But the algorithms, PageRank is PageRank, hasn't really changed. That doesn't get faster, but the data gets bigger, and so you have to know how to distribute those over 100 different nodes in a cluster, so that you get good response time.
There's really a value to be able to ask these questions and change reports and be really agile. And it's amazing when you see the really big companies, how much it costs to get a new report. And just that cost to get a new report, sometimes that scalability is just the ability to ask a lot of questions and kind of figure out what questions you really want to ask and how to get to that answer, versus really taking a long time to make sure the question is right for a report, because it costs so much to both ask the question to the database and to codify it into some kind of report. This is really compounded when you're moving data around. That's not based on business events. When you're moving data around, that's just replication, where you take a distributed autonomous system that's federated and you move it to a centralized location and then try to derive information off of it, just what happened in the operational system, not to mention what you want to do from analytics. So we've found a lot of situations like that, Dan and I have, where we've really been able to drop down costs. And part of it is the scalability of the database, but a lot of it is about the flexibility and the flexibility to ask different questions without having to re-index things and not having to bring other systems down.
If I could just do one more yes and on that answer to
Yeah.
your question. The fundamental algorithms for graph traversal have not changed, but there's one key thing that is different, and that is we have a new index. What is that index? It's called a similarity index. It means that we can take any two vertices or edges or subgraphs and say, how similar is this to other things? And we can use language models to do that, right? That is really different. Nearest neighbor, for example, right? If every one of our customers is described by a graph, you can convert those customers into a document, and you can create an embedding, and you can put them in a high dimensional space and say, this is how similar these customers are. And that is just an amazing new thing. Now, just to be really clear here, their venture capitalists have dumped about $400 million into new database companies that are called vector stores.
Okay.
And I got to say, I'm not convinced that one index is a new database type, right? Because every set of data could add a column for similar. You can take a spreadsheet, you can have a service, and you can say, here's the embedding for this row in the spreadsheet, right? And Microsoft is going to do that, right, for Excel. So you can point to a row and say, show me those most similar rows. That's trivial. That's a similarity index, right? But one index doesn't make a new industry. I would much rather take a really solid distributed graph database and add one index than try to build a new database from scratch without role-based access, without high availability, with all the other things that we hold near and dear in our databases. So just buyer beware, just because you have a new cool index doesn't make it a new industry. And so got to be very cautious about what the media is saying and what reality is. The bottom line is everything in databases like transaction control and distributed processing and remote backup, all those things are still relevant.
Interesting. You know, there's a real movement, and I've seen companies say this, like, well, Palantir, for instance, some of the graph companies, where they're saying, look, we have a lot of this stuff that was once traditional AI, the knowledge representation. And in order to make large language models really fly, you need to be able to connect the two of them. That's really going to be the enabler. What kinds of things do you think we're going to be able to do by connecting the two of these technologies that we haven't been able to do before? You mentioned one of them, which is the nearest neighbor. I'm wondering if you could just maybe get you guys to sort of speculate, elaborate, dream a bit. What are your thoughts?
Steve, you want to jump into that one? I've been doing a lot of nearest neighbor algorithms lately, so I have a lot of...
Yeah, I mean, that's such a special one too. I look at that company's source of data, right? The relational database is kind of the source, right? That's the secret sauce. That's the data that occupies. But making sense of that is really, really difficult. And what we did in our past, I guess, is leverage it, yeah, but we were feeding into the graph database, right? We weren't necessarily connecting the two through transactions. Now, is that something that's moving in that direction, Dan? Or
yeah, I see 1,000 flowers blooming here when you start to combine these things. And I'll just give you one example, and that's schema matching, right? So you have an input schema of a new set of data, you have your existing graph schema, and you want to merge them together. And you want to merge the metadata, not the data, right? Entity resolution is merging data. Yes, generative AI is making entity resolution much better, faster, cheaper. But schema matching, we used to do this thing called ontology matching, right? Where we maybe had one commercial ontology and another commercial, and we had to build our own and map those two together. In healthcare, we have UMLS, which has 600 ontologies it tries to map together, right? That's crazy. Gen AI can really, really help a lot of those things. Once again, they increase the speed of data coming in, and they increase their ability to match those things with queries that people want to ask of the knowledge graph, but they don't have the skills to write the queries themselves.
Wow, good answer. That's
good
amazing.
examples of that, yeah. And when I say 1,000 flowers blooming, this is such an incredible opportunity for startups, because the big companies. Here's an interesting, ironic twist. Google and Microsoft all run, LinkedIn, for example, all run on graphs.
Yep.
And yet neither of them actually sell a graph product, right? They have Cosmos DB, but that's really a document store, and they've wrapped a little graph thing. So Amazon is a little exception. They have Neptune, but you notice that they don't run their internal systems all in Neptune, right? Their product recommendation uses a much, much better scale out model. So there's just so much opportunity for new startups to not only build these systems, but then integrate knowledge graphs into any existing system and leverage large models. So I'm just looking forward to the next couple of years where you see all of these startups really start to build very cool resources that can be integrated into a company's infrastructure quickly.
Interesting. Steve, is there any words you want to add to
that? Disruption. So anytime,
wow, yeah.
Anytime we see change, it's obviously we're technical people, so we're always excited about disruption because the flashlight turns on us. And, I think that's the big thing with startups. When we've seen evolution, it doesn't happen, in a line. It happens as stepping stones, right?
Yeah.
And then it jumps up. And I think we're at one of those disruptive jump up points where now that we have these new abilities, people are really going to see how to leverage it. And we're going to look at, you and I, Bryce, have talked about looking at things in different lenses, from different lenses. And I think we're going to see human perspectives looking at what we can do now and coming up, looking at it from a different lens. And that's when we really see innovation. And that's where we really see evolution, is when you have such types of disruption.
Yeah, absolutely. The yes and there's really key. You can look at this just through the HR lens of skills and staff and how do you get those skills up. Completely different lens than just how we build technology. How do we get our people to be able to integrate this stuff? Teaching a prompt engineering class for every employee, absolutely essential to take the power of these things. And yet so many companies have fear that they might lose IP, that they don't do this. Once again, deer in the headlight look.
Well, Steve, Dan, thank you so much. This was a wonderful discussion. It brings a lot of more questions to mind now about what's going to happen, and I'm hoping we can talk again in the future about some of the stuff. I could definitely go for 6 to 8 hours listening to you. Again, thank you so much.
All right, great. Thanks for having us.
Cheers.